Okay, so May 2015, paper 1. We're starting with number 1 because that one actually, overall, was one of the most frequently missed. What do you think one of the problems was that made a lot of overall candidates miss this one? Degrees. Make sure that you have checked your mode and that it's in degrees. You should also, before testing, make sure that stack diagnostics is on. I will have this set up on your calculators, but if somebody stupidly goes second plus 712, it'll go back and erase that. So, calculate the exact value of t. Notice that it's 2 points. If you get it right, in the bottom, you get the 2 points. If you get it wrong, they're going to go back and look for a method point. What do you think they want to see for a method point? The work, like where you plugged in which numbers. So in your working section, you would do t equals. And I would keep all the parentheses like they have it, tangent of, and you could do 2 times 30, or you could actually write 60. Notice that it's 2z and then close parentheses plus 1. One of the mistakes a lot of people made is they forgot to close that parentheses. Then this would be 2 cosine of z, close parentheses, minus 1. Denominator, y squared. Y is 41 minus x squared, which is 9. Putting that in the calculator. If you're not careful and using the fraction feature, that's where a lot of mistakes can happen. So alpha F1 is the way to make sure you don't make mistakes. Parentheses, just like it's written, tangent 60, close parentheses, plus 1, close the next parentheses. Open 2 cosine 30, close parentheses. So you want to type it in exactly the way it's shown. And we should have gotten 0.00125. Yes? Okay. So, and it says to calculate the exact value, you would write the exact value here, 0.00125. Part B says to give your answer correct to 2 significant figures. Which is the first significant figure? This one. This is the next significant figure, so it would round to 3. The second part, take this answer and round to 3 decimal places. 0.001. That's 3 decimal places. Now, somebody, I can't pronounce his name, estimates the value to be 0.002. That's the estimate, is 0.002. What's the exact value? The 0.125. So, a lot of people made mistakes on putting this into the formula, in the formula book. Hi. Did you need me?
Yeah, I have math off right now.
Okay, well, hold on.
Are you keeping out the whole class period?
I don't know.
Okay, well, you shoot me an email.
Okay.
Can you do that?
Yeah. The formula in the formula book is set up like this. This is what it looks like. And it even says VE is exact and VA is approximate. So when we say this is the estimate, it's going to go in where it says approximate. One of the common mistakes is people divided by the estimate instead of the exact value. Now, if I did the fraction part, I got 0.6, and then notice it says times 100, and then put the percent sign. That's just showing you how to change it into percent. Take 0.6 and change it into a percent. Should have been 60%. Be very, very careful putting them in the calculator. Let's find another one. What was another one that y'all would like to see? Okay, number 2. Alright. We have a list of grades, and they're asking us to find the median. What should you do first? Put them in order. A lot of people forgot to do that. So, 2. There's a 3 and another 3. And then a 4 and a 4, and then a 5, 5, 5, and then a 6 and a 7. How many numbers, how many numbers are there? 10. So, halfway, be right in the middle of those two, right? 4.5 is the median. Quartile 1 is going to be halfway between the beginning and that median. Which number is halfway in that group of 5? 3. That's Q1. The first quartile would be the first quarter.
Okay.
This was halfway.
Right.
So quarter would be halfway from there to there. And then Q3 would be halfway between these two, which is 5.
So you're basically splitting it in half and then finding the median of each group.
Yeah. So when it says find the interquartile range, that's Q3 minus Q1. That'd be 5 minus 3, which is 2. Part C was missed a lot. Find the probability that a student chosen at random scored at least a grade 4. What does that mean, at least a grade 4? 4 or more. How many is that? 7 out of how many students? 10. So part C, all you had to write was 7 out of 10. I had some people put down 2 out of 10. What were they counting? How many times 4 was listed? But at least 4 means I'm counting 4 or above. Number 6? Yeah, we don't have to go in order, so number 6 is fine. Number 6. Pietro? Okay. Arrives in Singapore at the airport. He has 800 euros that he wants to change to Singapore dollars. The bank rates are given. Let's see. So we have the exchange rates from euros to Singapore, from Singapore dollars to British pounds, and they don't charge a commission. Okay, so how many Singapore dollars will he get? So he's got his 800, right?
One thing that was really confusing is whether to choose things
Buy or sell, like how do you do that?
Well, the bank is buying his euros and giving him...
Is it also selling the Singapore dollars?
No, because you're just exchanging it. So the bank is buying it, then they're not yet selling. They're not selling Singapore dollars to you. They're just buying your Singapore dollars.
They're buying them. Wait, what?
Yeah.
Well, I have no idea what's going on.
Yeah. Makes sense in my head, but
Yeah, I can see how that gets confusing.
give us a solution.
Let me think of a good explanation on why it's that one instead of the other one.
Is it like a certain phrase or something?
That's a good thing. Hold on. Let's see if I can find a good something that says something about the phrase. The location of the bank makes a big difference.
Okay.
So, if he just arrived in Singapore, what currency does Singapore use? So they have that, right? So he's bringing euros to them. So they want to get the euros from him, right? So they are going to buy the euros from him and give him Singapore dollars in exchange.
So they buy.
They buy it because it's new currency to them.
Okay.
Okay, does that help a little bit since he's in Singapore? Because he's in Singapore, they're going to buy it from him. So he gives the 800 euros. Each of those is 1.55 Singapore dollars. So you would multiply them together. So how much does he get if I multiply those two together? I'm doing my work up here just so we can look at the picture too. He gets 1,240, I think?
Yeah.
Okay. So, Petro also has 100 British pounds that he wants to change to US dollars for a trip to Cambodia. Okay. So where's he starting with? Can he go directly from the US dollars to, from the British pounds to the US dollars? Alright. So he's got to take that British pounds and get some Singapore dollars. Where's he at? Singapore. So first he's got to take those 100 British pounds. And if he's in Singapore, are they selling him those or buying? Buying. So times 1.92. So now he's got some Singapore dollars, right?
You got 192 Singapore dollars.
192 Singapore dollars. And he wants to, Petro wants what for those? US dollars. So now the bank is selling him the US dollars.
Why? Why are they selling that?
They'd be buying foreign currency,
It's just,
but since he's got Singapore dollars and he wants foreign currency, they're going to sell it to him. It's usually at a higher rate. So, if the bank is going to sell him, what, US dollars? So, that's going to be 1 US dollar is 1.28 Singapore dollars. Notice that they're charging more Singapore dollars for each US dollar when that's what you want. But if you had U.S. dollars and you were trying to get Singapore dollars, they give you a lesser exchange rate. So 192 divided by 1.28 gives you 150. Just to let you know, they would have given partial credit if you had gotten confused on which one to use, as long as you were consistent about the confusion. Like if instead of times 1.92 here and then dividing by this one, if you'd switched it and done 2.05 and then 1.15 on the other side, as long as they balance it out somehow.
Well, why is it divided by?
Because it's 1 U.S. dollar is 1.28 Singapore dollars, and he has Singapore dollars. Remember, he already changed his British pounds to Singapore dollars. So, since he's in Singapore, and he's bringing them foreign currency, they are buying his foreign currency. If he had Singapore dollars and wanted foreign currency, they're selling it to him. Does that help a little bit with that? I know those are really confusing. And the feedback on that one is many candidates lost at least 2 marks on this question for using an incorrect rate. The difference between bank buys and bank sells was not understood. The use of the table was not consistent. So don't feel bad. That was a common mistake internationally. So if that makes you feel any better, that people in other countries can't even do it. So buying is when you're bringing foreign currency to them, to a local bank. So if somebody came to us in the United States and had rubles from Russia, okay, so if they brought their rubles with them, our banks would buy those and give them dollars in exchange. If he had taken the rubles to a Russian bank, that bank would be selling him U.S. dollars to take with him. Because they don't normally have U.S. dollars, so they're selling that. Yeah? Okay. All right. That one was one of the frequently missed. What's another one? Y'all can kind of compare too and see which ones. And I know you didn't get a chance to finish it yet, but at least these will help a little bit on the study. And I am going to hand out the mark schemes, so the ones we don't go over, you can see how they're graded. 11. Okay, and that's fine. I don't mind.
Because for 11, we talked about
Oh, yeah.
and that's what we did.
Okay. So let's look at 11. Peter either walks or cycles to work. The probability that he walks is 0.25. If he walks, the probability he's late is 0.1. Probability that he is late if he cycles is 0.05. So they've actually shown this whole thing filled in. I do tend to go ahead and multiply each branch. Okay. I'm going to still do that.
0.25 by 0.1.
So I still do that times 0.1 is 0.025.
And that's 0.225.
0.225?
0.0375.
0.7125. Okay. On a day chosen at random, Peter walked to work. Write down the probability he was on time. So we already know that he walked to work. So this choice is gone. We already know he already finished this. He's already walked to work. What's the probability that he's on time if he walked to work? 0.9.
Is that the answer?
Yep.
Yeah, I did that.
See, it just seems too easy.
A different day. So notice the difference in the wording. This one said we know he walked to work, period. The next one says find the probability that he walked to work and cycled to work and was late. That and means those are multiplied together. So technically we should have done 0.75 times was late 0.05. This one is the and, so they're put together. It's the chain reaction. First we have the probability that he cycled, then the probability that he's late, so this one's the 0.0375.
I got that wrong.
Did you write 0.0375?
Yeah.
In your answer box at the bottom? Did you put 0.0375%?
Yeah.
What would this be in percent?
That's a different answer.
Yeah, 3.75%. So be careful of that. The probability that, now here's the ones that are weird. Given that Peter was late, that he cycled to work. So first, do we know the probability of cycling and being late? 0.0375. That given means we need to divide by the probability that he was late at all. So this one does get a little confusing. This is the probability that it's cycle and late. And we need to divide by the ways he could be late. What's one option for being late? Walking and late, 0.025. The other option was the one we already have, 0.0375. And we would add those together. This one was highly missed. And I see why. It's worded very strange. A lot of people just put the 0.0375 again. You just asked that question. Does that make, I mean, the way they worded it really was strange. This is the probability that he was late overall. This was that if we include cycling and that he was late. And it should have been 0.6. Or 60%. No, you can write it either way. So on that one, would we maybe have been able to get A and D? And maybe a little bit of partial credit on C, even with the weird wording. I'll be honest, those compound probabilities always mess me up too. If that makes y'all feel any better. So like the conversion rates sometimes mess me up as well. That's why I have to think about who's walking into the bank, where it's at.
Okay, then like the rest of them?
Yeah.
Okay, but is there another one? Did anybody else have one that they wanted to see?
I did 8.
8, sure. Eight. That's okay. 8, 8, 8, 8, 8. Oh, okay. We have a 6-face die, and we have a 4-face die that has these numbers written on it, and we're supposed to complete the Venn diagram. So, what's going to go in the middle Which ones do they share? 2, 3, and 5. What's just going to be in the A dice? 1, 4, and 6. And this one's just going to have a 7 right here, right? Okay. Most people got that part fine. Part B. Find the number that's B and, what's that dash mean? Not A. So how, that N means how many things are in B but not in A. This means the number of elements, the number of things. So how many things are in B but not in A? They also gave credit if they saw, or like method credit if they even saw shading, like if you shaded right here, you would get like a point for showing that you knew where that area was. B and not A would be right here. Okay. The next part is probability. Whoa, and my phone's ringing. I went back to my LSU one. I don't know who you are. Okay. Alright. So they're each going to roll their die once only. Assumes there's a probability that each die will show the same number is 1 out of 8. Okay. Alright, so same number. What are the ways we could get the same number? Both 2, or both 3, or both 5. How would I find the probability that they're both got a 2? What's the probability of getting a 2 on that 6-sided die? 1 out of 6. The probability of getting a 2 on the 4-sided die is 1 out of 4. The probability of both the same number is 1 out of 24. Multiply across.
I'm so confused right now. How did you get, I understand how you got 6, but what's the point of that?
The probability of getting a 2 on the 6-sided die is 1 out of 6. The probability of getting a 2 on the 4-sided die is 1 out of 4. So the probability of doing that is 1 out of 24 chances. So what would be the probability of both 3s? Same thing. Probability of getting both 4s.
5.
Oh, 5s, I mean. Same thing, right?
Correct them in 2.
So we have this way, or this way, or this way, for a total of 3 out of 24 ways. Another way you could have done this one, just to let you know, is to list out all the different possibilities.
Right.
You could have rolled a 1 and a 2, a 1 and a 3, a 1 and a 5, a 1 and a 7, right? Then we could have rolled a 2 and a 2, a 2 and a 3. What you're going to end up with is 24 groupings.
So she is correct.
It was correct. And they took listing out all your sample spaces, making a tree diagram. There's several ways it could have happened. Another way some people did it was they made a kind of a chart, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and made little squares. How many squares do I have? 24. So Whoops, this wasn't 1, 2, 3, 4. What was it? 2, 3, 5, and 7. Correct?
Correct.
The ones that are the same. 2 and 2 is here. 3 and 3. 5 and 5. Those are the only 3 ways you have the same numbers. So 3 out of 24.
So, it says, give a reason.
This would be a good reason.
If it's drawn over there, that's not on the answer box. So can I just say, drawn above?
Yeah.
Okay.
Just say C dot, C picture. I know that one was kind of... But hopefully we could have gotten the first 4 points.
Yep.
Or, I hope so. Okay. Remember, you're trying to gain as many points as you can. What's another one? 5. We're going back to number 5. I think that's a volume one. Yep. Okay. Perfect sphere with radius 6371. Calculate the volume. First thing I would do is find the volume formula in my book. And I think some people copied it down wrong. So it should be 4/3 pi 6371 cubed. And they want it in this weird form, something times 10 to the something. Oh, isn't that scientific notation? So 4/3 times pi times 6371 to the 3rd power. Oh, look at that, isn't that nice? What's that E12 mean? So 1.0, you could write the whole thing, or just go 1.08 times 10 to the 12. Do not write the E, they don't want to see that.
So that still makes sense? It's like if it's not rounded to like 1.08. Because I thought like 12 is this many, whatever, and so if I rounded it to 1.08, then like the 12 would have to increase.
No, because the decimal place has not moved.
Okay.
It's still after the 1. I'm just not writing all those digits after it.
Is it okay if I do?
You could write your entire screen. The volume of the moon is given here. How many times greater is the volume of the Earth to the moon? So we're trying to find out how many times greater. So 1.08 times 10 to the 12 divided by 2.1958 times 10 to the 10th. I would have taken that last answer that I got, divided by, parentheses, 2.1958 times 10 to the 10th. And it said, leave your answer to the nearest integer. Do you want to write your entire calculator screen on that one?
No.
If it says nearest integer, that's 49.
That's it?
That's it. Is there any more you need to do whole group?
Can we just like do a super quick review over 7?
7? Oh, sure. 7 is using the formula chart a lot. So we're given the second term of an arithmetic sequence and the fifth term, and we're supposed to calculate the common difference. So, number 7.
What does A2 mean? What does A2 mean? For the answer.
A2, 2 points for the answer?
Oh, yeah.
Okay. So common difference means how it was added, right? There's several ways you could do it. One way would be to go, I'll have a first term, then the second term. This would be third term, fourth term, fifth term, right? Okay, so let's see, what would I have added each time to get there? What's the difference between 90 and 30? It's 60. So I added it, and added it. What did I add? 20. If I added 60 overall, and we went 3 spaces, that's 20 each time.
And then find the first one, like I could just subtract 20 and
Yep.
make 10. But isn't there like a special formula?
There is if you'd like to use it, but if you draw it out, they're fine with that too.
Okay.
I mean, we could have done the formula, which in the formula book is u sub n equals u sub 1 plus n minus 1 times d.
But how would you?
So if we knew the common difference and we knew one of the terms, like let's say that this term is the fifth term,
Okay.
90 equals u sub 1 plus, it's the fifth term,
Or
times the difference, times 20.
oh, and then okay.
But if you draw out the pattern, they're fine with that as well.
Okay.
Just recognizing arithmetic means I'm adding the same thing each time is fine. The next one says if you took the first, second, and fifth terms of this sequence here, those are actually the first 3 terms of a geometric. What is the difference for the geometric? So what's happening each time if this is the new sequence? Times 3, times 3, times 3. The next term would be 270. We're supposed to go up to number 7. Could you do that? Yeah. I want to show you the mark scheme. This is a perfectly fine method. You could have also used the formula. The formula says any term can be found by the first term times the common ratio to the n minus 1. First term is 10. We're multiplying by 3 each time. And we're looking for the 7th term. So 7 minus 1. If you do not remember how to use these formulas, write out the pattern. And you would want to show the whole pattern to get credit for that as a method. But it is a perfectly fine method. Now, if they ask for the 100th term, I'd advise against it. Because 100 terms, that's going to take up all your time. That would be very long. Okay. Okie dokie. 12. Whoa, moving on. You're jumping way over there.
Can I just put 12 points through the rest? That's just someone said no one got it.
Okay, well, we got it. Okay, so they give us an equation, a linear function. L is the length, T is the temperature. Okay, so we've got L equals M. Well, that's kind of like the slope, right? Plus C at the end.
So this looks like the equation right
Uh-huh. So in the first one, they give us a temperature and a length. And it says write down an equation that knows that. Length M times 150 plus C. All I did was plug in the temperature and the length.
That's the equation?
It says write down an equation that shows this information.
And see, that is easy.
Part B says write down an equation that shows the new second piece of information. Okay?
Are you for real? Or not?
Yeah, I think that was
Now there's a couple of ways to get to the next one. Part C is the 4-pointer.
Wow.
Alright. So one way to do it, isn't this kind of acting like a Y? And isn't this kind of acting like an X?
Isn't that kind of like, oh.
Uh-huh. If I'm gonna, like, I need to find out what M and C are, right? That would be so helpful. Now, one way the reason they set it up like this is that you could actually do something called elimination. Do you remember doing this?
Destroy the math problem with a gun?
Or like, if I subtracted one of these equations from the other one,
Yeah, but that's still a lot of work.
is it?
That's,
I tried doing that actually too.
If I subtract the second one from the first one, 181.5 minus 180 is 1.5. 210 minus 150 would be 60
Correct.
times the M. What happens to the C's?
Well,
They're gone, right?
wow.
C minus C. Okay, so I have 1.5 equals 60M. Somebody take 1.5 and divide by 60.
0.065.
John, the only time I do something.
Okay? So now I know M. What else would I like to know? C.
Just plug it in.
Plug it into either equation. 180 equals M, 0.025, times 150 plus C. And that's really all the work I would actually have to show, and then I would do 180 minus 0.025 times 150. I get 176.25 equals C. This would have given you 1 point. This would have been 1 point.
why did I skip this one?
I know, I'm like, L equals NP plus C.
Bye. Later.
Once you know M and C, you have your real equation. M is the slope, C is your y-intercept. And then it says find the length when the temperature is 40 degrees. You would plug in the temperature. Notice that this is number 12. This is, how many people really get all the way to number 12? Small percentage. Let me find my actual feedback and tell you how they did on this one. What did I do with that? Oh, it's over here. Number 12. Part A and B were given correctly by the vast majority of candidates. Part C, in most cases, was either completely correct or no marks at all.
The answer?
Some people guessed at Part C, and some people got lucky. So, but does that make sense on the process there? I would have at least tried for the first couple of points. A and B,
Sometimes it just seems way too easy and like, well, this is an ID test, one be the easy.
if it's a one-pointer, it's going to be easy.
Okay.
All right. I believe 14 was also one that was, I noticed was missed a lot. 13 and 14, because y'all didn't get there. Do we need to do 13 and 14? Okay, we'll see if we have time. 13 says we have normal distribution. Normal distribution is the one that does that, right? Okay, this is in the calculator. The whole problem is in the calculator.
I don't remember anything.
So, there's something about distribution in the calculator. See if you can see where D-I-S-T or...
It's in bars. What did you call me? Bars. Okay, John.
It's like second to bars.
normal CDF.
See? See, I thought it was one of those that I was
And that's the hard part. You have to remember which one. Now,
It's not PDF because we don't have a Adobe Reader and Calculator.
okay, let's follow it that way. We're finding a bag that weighs between 990 and 1,004. Lower bound is 990. Upper bound is 1,004. This weird U thing, what's that? The mean, 1000. And the squiggle is the standard deviation. So I would have wrote down for my answer 0.835. B and C were the ones missed a lot. Because it's not so easy. I'm telling you, 12, 13, 14, and 15 are usually the ones people never even get to. These are really the ones deciding between the 6 and the 7s. Because most people don't get here. If 95% are less than a certain value, that means that value K is like right here, right? And here's all the other bags of rice. Are you with me on that?
Sure.
So this is 95% of them. I want to make sure. Right. Oh, yeah. Oh, that was right. Okay. All right. So we're going to go back into the distribution. And this time we're given the percentage. So we're doing the inverse. We're doing the inverse operation. So it's inverse of the normal. The area is that 95% that's below that number. The mean is the same as it was. And this might be something I did to show my steps to the grader, so they could kind of see where the mistake might have been. And it gives me that K is 1,004. 6.579, something like that. Okay, the last one is confusingly written.
Yeah, it's right.
The probability that if I took 1,000, wait, what's 1,000 in that problem? The mean, and subtracted A as my low boundary, and this is 1,000 plus A. So what they're really looking at is if I took my mean, which is down the middle, if I added A, this would be plus A, this would be minus A. Are you with me?
Yeah.
This area, they're saying is 0.9. How much would be below in this spot? And how much would be above the shaded area in that spot? If this is 0.9, or 90% is in this area. Wouldn't that leave 10% for each of these? So 0.05 and 0.05. One way you can actually do this problem, wait, wasn't this 95%?
Yep.
That means there's 5% there.
Pardon the interruption. There are two cars in the black box that need to be moved immediately, or they are trimming a tree. One is a silver Volkswagen Beetle, license plate CA1.
Oh, I'm recording. Excuse us on the recording.
One is a silver Fiat, license plate SBH5560. A silver Volkswagen Beetle and a silver Fiat. In the black lot, you need to move your car right away.
This line right here, where we took the mean and added something, is actually in the same place as that value we just found. So what was added? So from 1,000 it was 6.579. That one was ugly. Most people didn't even get to that problem, and they most got A right. Very limited number got C.
Can you go over what you just said?
Okay. 90%
Right.
is in here. Let me rewrite these instead of as point. This would be 5% then,
Okay.
and 5%.
Yeah.
Well, in the last part, we had a boundary with 95% of all the bags below it.
Okay.
So that means 5% were above it. Doesn't that mean that line's in the same exact spot?
Yeah. Okay.
So this line right here is at 1006.579. The median was at 1,000, or the mean was at 1,000. How much was added?
Okay.
I know. That one, I would have skipped it. Good. Alright, I guess we can do 14 and 15 if y'all want. 14 has a quadratic function. It says that the graph passes through the point 60. That's an x-intercept, right? Okay. Let me put this one also in parentheses. These are factors. Do you remember that you could take a factor and set it equal to 0 to find x-intercepts? You do now. So if I had some number times x, and I set that equal to 0, what's the x-intercept from that factor? Isn't it just 0? Yeah? No, y'all don't remember this? Okay. If I set this one equal to 0, I would get q equals x, right? So one of my x-intercepts is 0, and the other x-intercept is some number. They gave us that it went through point 60. So 6 has to be the other x-intercept. So 6 is q.
You know what? I think that would make more sense if I had to agree.
They basically gave us the answer right there.
Okay.
Now, the other way you could have done it, let's say you didn't notice that, okay? What if I took, let me do the other way to do this. We're given a point, 60. Can I plug it in? Okay. 0 equals p times 6, and then q minus 6. So what happens here? I need to divide by 6p, right? What happens 0 divided by anything? Solve for q. So q is 6. Does that make more sense that way? Okay. All right. All right, so now we know what q is. They give us another point. They say the vertex is at 327. Could I put that point in? 27 is the y value. I'm going to plug in 3 for all the x's. That's 3p. 6 minus 3 is 3. 27 equals 9p. What is p? Three. From here you have the actual equation. You could put it in your calculator if you wanted to, but you're given all the information you really need to answer the last question. What is the range of the function? If we know where the vertex is, and it says the vertex is at 327, what's the range? Everything less than 27. I know. The way it was written wasn't pretty. All right, 15. We're moving, flying through this. Whew. Oh gosh.
Oh no.
Okay, we got a prism. says we've got width is x, 2x, and the height is h. The total length of all the edges is 72. Okay, so that means if I add up every single edge, it's going to equal 72.
So every single edge, not including like some of it else.
So here's an edge. How many of those x's do I have? Isn't that just here, 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 and one kind of hiding back here? There's 4 x's. How many of these that are the long way across? 4. And then how many heights? 4. That is supposed to equal 72. 4x plus 8x plus 4h equals 72. They always give you one bit of information that you should probably plug in. The next part says something about the volume, and it's got this weird formula. It's got like x squareds and x cubes. I bet I need to use the formula for volume. So I'm going to come over to this side. How do I find volume of the prism? Is it length times width times height? Well, the length is 2x. The width is x. And the height was just h. Do you see any h's in their expression? In this one? No. Can I rewrite this one for h?
Yeah.
4h equals 72 minus 12x. What's 72 divided by 4? 16? 18. 18, I think. Minus 3x. Okay. So height is now represented by 18 minus 3x. But they want us to have our volume looking like this. What should I do? Should I just distribute it? This is 2x squared. If I distribute, 2x squared times 18 is 36x squared. 2x squared times negative 3x is negative 6x cubed. Yeah. So now you know what A is. What's A? A is the number in front of x squared, so A is 36. There are several ways you could do part B. Could you sketch a graph on the calculator and find the maximum? There is. I'm going to go over both ways. Y equals, clear, 36x squared minus 6x cubed. And my window's kind of, my window's partly okay. I can see where it came down. Do I see where the maximum is? No, so I play with my maximum here and just guesstimate until I see the whole picture. Do I see the maximum now? Second, count maximum. Left bound. And then write down 3.99999999994. X equals 4. On my paper, I might have done this and then put 4,192. So they at least knew I looked at the sketch. The non-calculator way to do this is, what's the slope? 0. At a maximum, the slope, the derivative would be 0. That's the other way to do it. I would have to find the derivative of that. How do you find the derivative? So the exponent goes down, 72x goes down minus 18x squared. We want to find when that equals 0. This is faster.
Wait, how do you do that?
I put in this function and zoomed out until I saw the graph, and then the maximum was under second count. That's the easiest way to do it. Yeah, I'm being honest, that's actually the easiest and fastest way. Whew! Brains hurt?
A little bit.
A little bit? Okay, so I'll record, probably not today, because I don't know, I'll see what I have time for. But I've got the ones all on paper 2 posted to YouTube already. So paper 2 you can review there. Come back up here. Let me stop the video.